Welcome to solving word problems that are area and perimeter that involve radicals. Let's just start by remembering how we do a perimeter problem. So determine the perimeter and state if it's rational or irrational. We're going to determine the area and state whether it's rational or irrational. So how do we determine the perimeter? So remember, when we are trying to find perimeter is all the sides added up together. So it's the distance around all the sides. So let's just write all sides added together. Okay, if you want to put that it's the sum of all the sides, sum means you're adding. I'm just spelling it out so it's very clear. Okay. How do we determine area? Okay. Area, we're going to have two different formulas that we're going to look at because we're really going to talk about two different shapes in the stuff that we're talking about. We're going to talk about squares and rectangles, so that's the one shape, and then triangles is our other shape. Okay. So what we have is, if we have a square or a rectangle, then the area is length times width. Okay, but if we have a triangle, okay, then our area is going to be 1/2 times the base times the height. Okay, so these are the two equations for area that we need to be very familiar with and be able to use at any time. So number one here, we have a rectangle drawn for us, and it says we're finding the perimeter and stating if it's rational or irrational. Then we're going to find the area and state if it's rational or irrational. So the perimeter, remember, is all the sides added up together. So what I'm going to do is I'm just going to label all the sides. So what's nice is I've got a square root of 7, which that is simplified, so I'm going to leave it in its simplified form. And then 2 square root of 3, which is also simplified. So since all 4 sides are already simplified, there's nothing else that I have to do except for write them on their corresponding side. So perimeter is just adding up all of those. So I've got 2 square root 3 plus the square root of 7 plus 2 square root 3 plus the square root of 7. And here all we're doing is we're finding the ones that are like with each other based on their radicand. And then we're going to add them together. So 2 square roots of 3 plus 2 square roots of 3 is 4 square roots of 3. And the square root of 7 plus the square root of 7 is 2 square roots of 7. That would be the final answer. And none of those are perfect square roots. So that means that this is going to be irrational. Okay. For the area, we're going to the area formula for a rectangle. So this is length times width. Okay, it does not matter if you call the square root of 7 the length or the width. Just make sure the square root of 7 is one of them and 2 square roots of 3 is the other. So we have 2 square roots of 3 times the square root of 7. So remember, when we are multiplying, we multiply coefficient times coefficient and radicand times radicand. So 2 times this understood 1 is a 2, and then 7 times 3 is 21. 21 does not simplify down at all. If you break it down into its prime, it's 7 times 3, and there's no perfect squares there. So it's 2 square root 21. That is also irrational because it's not a perfect square. Our next example says Katie is making a square garden in her yard. So if we stop there, right now we know that Katie is making a square garden. Well, that means draw yourself a picture. A square garden means all 4 sides are the same length, and the next sentence tells us the length of the side is the square root of 5. So that means all 4 sides are going to be square root of 5. Then we're going to find the perimeter and the area. Well, this is easy. We have 4 sides, and they're all square root 5. So square root 5 plus square root 5 plus square root 5 plus the square root of 5. So that means I have 4 of them, so we have 4 square roots of 5. Again, this is not a perfect square. The square root of 5 does not break down. This is irrational. For the area, remember, area is length times width, so we're taking the square root of 5, which is the length, and we're multiplying it by the square root of 5, which is the width. Okay, so this is going to give us the square root of 25. Now remember, 25 does break down. Sorry, that's supposed to be a 5. It's 5 times 5. Or you could recognize that 25 is the perfect square of 5. Because that was a perfect square, it now is a rational number. Excuse me. Okay. I'm going to let you try this one. The thing that we need to do first on this one is simplify the square root of 27. So I'll help you do that before you get started on this. So we're going to take our 27 and we're going to simplify it. So 3 times 9 is 27, and 9 is going to be 3 times 3. So that means we're going to get a pair of 3's and a 3 left over. So instead of using the square root of 27, we want to use 3 square roots of 3. So go ahead, take a minute, and find the perimeter and the area of number 3. Okay, we should get that the perimeter is 8 square roots of 3, and that's an irrational number. And for the area, we are going to get 9, and that's a rational. So we see that we ended up getting a 3 square root 9, and the square root of 9 breaks down and becomes 3. It's a perfect square. Therefore, we end up getting a rational number. All right, on number 4, it says, I'm building a rectangular basketball court in my backyard. Stop. Draw yourself a picture. A rectangular basketball court. That means you're drawing a rectangle. Now, what can we label on it? It says that the width will be 3 square root 7 meters. So 3 square root 7. I'm going to label it on both sides. And then it says that the length will be 2 square root 5. So I'm going to label it on both sides. So now all 4 sides are labeled, and let's find the perimeter. Okay, so go ahead, now that we've got a picture labeled, find the perimeter by adding all sides together, find the area by multiplying the length times the width, and check your answer. Alright, so what we get here is that the perimeter is 6 square root 7 plus 4 square root of 5, and that's irrational because both of those do not turn into perfect squares. And then for the area, we get 6 square root 35, which is irrational. Okay, when we multiply 7 times 5, we get the 35. 35 does not break down into any pairs, so it stays that square root of 35. All right, so we looked at rectangles, we looked at squares. Now let's look at triangles. So here we've got a triangle, and it says 2 square roots of 3, 2 square roots of 3, and a 2 square roots of 5. So we're going to find the perimeter. Again, the perimeter of a triangle is just adding up all the sides. In this case, we only have 3 sides to add up. So we're going to take all 3 sides and we're going to add them up. Now, when we add these, remember, we can only add the ones that have the like radicands. So only the 2 square root 3 plus the 2 square root 3 can we actually combine. So this becomes 4 square roots of 3 plus 2 square roots of 5. And those end up staying as radicals, so that means they are irrational numbers. The only way that it's going to become a rational number is if it ends up being a perfect square and you get a nice integer. So let's look at the area. So remember, area for a triangle is 1/2 times the base times the height. So we need to make sure we understand what's the base and the height. The base and the height make the 90-degree angle. Okay, that is this piece right here, the 90-degree angle. Is that little symbol in the corner that makes it look like a box. So that means this is going to be our height and this is going to be our base. The diagonal there we don't need. It's called a hypotenuse, and it's not part of our equation to find the area. So what we need is 1/2 times the base, which is 2 square roots of 3, times the height, which is 2 square roots of 3. Okay? We're doing the exact same thing we've done before. Coefficients get multiplied together, and radicands get multiplied together. Okay? So I've got 2 times 2, which is 4, and then 1/2 times 4 is 2. Then we have the square root. 3 times 3 is 9. We should all remember that 9 is the perfect square of 3. So I'm going to take that 9, that square root of 9, and replace it with a 3, and this becomes 6. Now that it's a perfect square and it becomes a nice integer, that means it's a rational number. All right, so let's look at number 6. Number 6, I'm creating a right triangular patio. So stop. That means we need to draw ourselves a picture. So let's come over on the side. I'll do mine over here. We're making a right triangular patio. So that's going to be our right angle, and it's a triangle. It says the base will be 2 square root 20. So the base we set as this bottom line, 2 square root 20. The height will be 3 square root 5. So this is the height. Those are the two sides that make that 90-degree angle. And then the diagonal will be 4 square roots 40. Okay? Now, this one's a little bit trickier because you should be able to look at this and see that the diagonal and our base are not simplified. So what we need to do is we need to simplify the diagonal and the base. So that means down under here, I'm going to break down the 40. So this would be 2 and 20, 2 and 10, 2 and 5. So that means we had a pair of 2's, and then the 2 and the 5 left over give us a 10. So that means I've got 2 square roots of 10 in place of that square root 40. So 4 times 2 square root 10. So this is 8 square roots of 10. We're going to do the same thing for the 2 square root 20. So we're going to take the 20 and we're going to break it down. 2 and 10, 2 and 5. So we have a pair of 2's, and then that 5 left over. So we get a 2 and then the 5 left under the radical. So this becomes 2. Now we're replacing the square root of 20 with the 2 square root 5. This becomes 4 square root 5. So now, when we start doing our work, we're using 3 square roots of 5, 8 square root of 10, and 4 square roots of 5. Hopefully at this point we see, hey, now we've got some radicands that are the same, so that might help us. So let's go ahead and find the perimeter. The perimeter is adding up all the sides. So 3 square root 5 plus 4 square roots of 5 plus 8 square roots of 10. So these first two are our like terms because they have the same radicand. So this ends up being 7 square roots of 5 plus 8 square roots of 10. And that is going to be irrational because it is not a nice, pretty whole integer. Then our area, remember this is a triangle, so we're doing 1/2 the base, which is 4 square roots of 5, times the height, which is 3 square roots of 5. Sorry about that. So we are going to multiply coefficients with coefficients, radicands with radicands. So half of 4 is 2, okay, and then 2 times 3 is 6. And then the square root of 5 times the square root of 5 is the square root of 25. We should know that the square root of 25 is the perfect square of 5. So this gives us 30. 30 is a nice whole integer, so that is rational.